Yes, Ernest here. Welcome to our channel. So today we're going to look at the difference between these two specific bases. These two specific nucleic acids. This is the DNA and RNA, respectively. Now, on our left side of the board, I've given the illustration for this specific bases, which we refer to as nucleic acids. And this was basically trying to show how these attachments of this nucleic acid in the DNA and the RNA strand, respectively. Now, in trying to show the difference between the two, we said that we have what we call the oxyribonucleic acids and the ribonucleic acids, respectively. And in that structural formation, we're going to see that if we try to compare the structure of the DNA and the RNA, we're going to see that there's a phosphorus, a phosphate molecule at this specific point trying to attach to this sugar, and we refer to this one as a phosphodiester bond. Now, at this specific point of attachment, we're going to see that there's an alternating formation whereby at this specific point of O, it's attached to a CH2 group to the sugar, CH2 group to the sugar, CH2 group to the sugar. And at this specific point for this, we're going to see that it's going to be this is carbon number 5 and 3 respectively, going to form a carbon or a phosphodiester bond at this specific carbon number 5 prime and 3 prime respectively. So this forms the points of attachment for both the DNA and RNA molecules respectively. Now we're going to see that if we have a DNA strand and try to contrast it with this other one, the first difference that we're going to see is that there's a OH molecule for the RNA structure at this specific point of the sugar, but for the DNA structure is just not having that OH group, as we can see in this specific alternating trend. Now for the bases which are being attached at this carbon number 1, we're going to see that these specific bases are just the same for the RNA and DNA strand, only for one particular base, which we said which is absent, which is a thiamine, is absent in RNA, but basically being replaced by a uracil, whereas in DNA there's lack of a uracil, which in its place is being replaced by thiamine. Now that's the difference between the two specific sets of strands for RNA and DNA, respectively. Now if you try to look at these specific bases that we said, there are 5 in number. The first one being adenine, which is made up of these nitrogen heterocyclic molecules, and then we have this nitrogen and an amine group at that specific point. And this one also we have got this is a carbonyl carbon at those two specific points for thiamine, and then this one has a combination of the two for oxygen, and the amine and nitro group are this specific nitrogen molecule actually has a replaced carbon, and this we have already discussed under the concept of heterocyclic molecules in organic chemistry. Now we can go and check on that. So this is known as guanine, the structure of guanine, the structure of uracil, and basically if we try to look at the formation of these two specific molecules, we can see that it's a 6-member ring which is attached to a 5-member ring. Now we refer to this particular formation or the product category of these particular molecules with that kind of a formation as purines, which I've illustrated at this lower side of this chart. Now in this case, we're going to see that adenine and guanine basically fall under this product class of purines, which are illustrated on the board as such. Now for the molecules of thiamine and cytosine, which basically are this one and this one, they have a 6-member cyclic heterocyclic ring, which falls under the product category or class of compounds we refer to as pyrimidines. And of course, we can see that the 3 of them have just a single cyclic ring as compared to adenine and guanine. So basically, these are the bases in nucleic acids, which we are referring to as DNA and RNA, which are alternating these specific points of carbon number 1 for each of these two strands respectively. Now, talking of the carbon number 1, I've already discussed in one of our videos how we can attain the cyclic imiacetals or maybe the cyclic forms of these specific carbohydrates. And as we had mentioned earlier, we said that actually this genetic, or rather these specific molecules that carry genetic materials are derivatives of carbohydrates, which can be able to be attained maybe using these specific cyclic forms. Now this is carbon number 1, 2, 3, and 4. And this specific carbon number 5, we have an attachment to this specific phosphate molecule. And this carbon number 3, we have an attachment for another phosphor. The phosphate molecules respectively. So the sugars are going to be attached, the bases are going to be attached at carbon number 1, and that is going to form the same formation. Now remember the difference between thiamine and the uracil for the DNA and the RNA molecules respectively, and these are the individual classes of bases of a nucleic acid. Now this one combined with the first video that we have done on the concept of introduction to genetics, and other 2 videos for the basic structure of RNA and the DNA respectively. This is going to give us a clear picture of these particular molecules are going to have an arrangement and maybe influence our genetic composition. I hope this is understood as insofar as the basis of a nucleic acid, which are contained in nucleic acids, are concerned, and there are alternating arrangements now which is going to intertwine and change to form a double helix for DNA and basically a single strand for RNA molecules respectively. So I hope that is going to assist us to comprehend more on this concept of DNA and RNA. Let's meet in our next video that we're going to look at perhaps in the hydrogen bonding that I talked about, and basically which is going to form a last bit of our discussion on the DNA, structure of DNA and RNA respectively. So that is it for today, guys. Bye. Let's meet in our next video. God bless you.